acids produce ions only in aqueous solution? To find the answer, let us do some experiments. Take about 1 gram solid NaCl in a clean and dry test tube and set up the apparatus as shown. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Test the gas evolved successively with dry, blue litmus paper. And wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above activity, what do you infer? This experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of H plus ion from HCl molecules does not occur in the absence of water. The reaction being HCl reacts with water to give hydronium ions, that is, H3O plus and chlorine ions. It is very important to understand that hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus, hydrogen ions must always be shown as H plus ions or hydronium ion H3O plus ions. It can be represented by the reaction as hydrogen ions react with water to form hydronium ion H3O plus. Now here we have seen that acids give H3O plus or H plus aqueous ion in water. Let us see what happens when a base is dissolved in water. The reaction will be NaOH S is dissolved in water. It gives Na plus ions and aqueous plus OH minus aqueous ions. Similarly, if KOH S is dissolved in water, it gives K plus ions plus aqueous plus OH minus aqueous ions. Also, if MgOH2 S is dissolved in water, it gives Mg plus 2 ions and aqueous plus 2 OH minus aqueous ions. So we can conclude that bases generate hydroxide or OH minus ions in water. Bases which are soluble in water are called alkalis. But do you know all bases do not dissolve in water. An alkali is a base that dissolves in water. They are soapy to touch, bitter, and corrosive. Students, it is very important to understand that we should not taste or touch them as they may cause harm to us. So, to conclude, all acids generate H plus aqueous. And all bases generate OH minus aqueous. We can view the neutralization reaction as follows. Acid plus base gives salt plus water, or H plus X minus plus M plus OH minus gives MX plus H2O, where H ions from the acids react with OH minus ions from the base to form water. Let us see what is involved when water is mixed with an acid or a base. Take 10 ml water in a beaker. Add a few drops of concentrated H2SO4 to it. And swirl the beaker slowly. Touch the base of the beaker. Is there a change in temperature? Is this an exothermic or endothermic process? Repeat the above activity with sodium hydroxide pellets and record your observations as shown here. From the experiment, we understand that the process of dissolving an acid or a base in water is a highly exothermic one. Care must be taken while mixing concentrated nitric acid or sulfuric acid with water. The acid must always be added slowly to water with constant stirring. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to excessive local heating. You will generally find warning signs on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. It is important to understand that mixing an acid or a base with water results in a decrease in the concentration of ions, H3O plus, OH minus per unit volume. Such a process is called dilution, and the acid or the base is said to be diluted.